Before we get started, I'd like to thank my first two patrons, Jeff Holbrook and John Lombard, who have graciously subbed and decided to support my work after only a couple of videos. I didn't think a community would form this early, but I'm really humbled by the support. So again, thank you. Hello Internet, welcome to the 3D Print Era channel. Today we're going to be reviewing the RC Benchmark 1580-85 series test stand, which is the most functional, I think, for the most common quadcopter motor sizes, from the smaller DJI Mavics to the larger Phantoms, racing quadcopters, and all in between there. What you can see here is the test stand itself. We've got coming in and out of the actual test stand is the USB cable plugged into the board and the power cables you see here. And that's all the input and output we have currently. And this is the lifesaver right here. Definite excellent upgrade for the machine. Allows you to easily swap in the ESC and easily swap out the motor cable order, which is really helpful. If you plug in a motor and it's spinning the opposite direction you require / desire, then you just flip one of these, and that really saves a lot of time. Alternatively, you could use banana plugs here, but that's a pain in the butt because then you have to solder them to every motor you get, because they don't come with those these days. And yeah, you just end up wasting a lot of solder and plugs that way, and then end up putting them on your ESC as well. So this is easy to switch out the ESC. Right now I've just got a Brother Hobby 2507 on there and a generic heatsink from TBS 30 amp with two actual aluminum heat sinks I put on it because it's not going to be moving through the air like it normally would. This test stand comes with 3 gauges on it, right here, here, and here, and they can all be calibrated. There's a calibration in the manual. You get this kind of mechanism here which you can attach in different places, and this 200 gram weight, so you can put it this weight and use this to apply torques. So it's really high quality in that sense. It's fully user manageable. You can calibrate it yourself, of course, and perform your own maintenance, and the software is really great. So a couple other things I'd like to talk about is how to put the propeller on these things easily. And this is great. This test stand is great because you can configure the direction and calibrate it for either direction and switch it in the software. But usually how I use these things is I actually thrust this way, and then the force gets read as a positive force in this direction. So put the propeller on this way, and an easy way to mount it is to use not a lock nut but something like this, which in this case the propeller rotates clockwise from this perspective. So if I get a conventional nut like this, one of the nose cone shape ones without any lock nuts, I can simply twist it on pretty quickly. And because it's a conventional screw or a conventional thread, it's not a counter thread, all I need to do is give it a simple tighten right there, and it won't ever come out because the drag of the propeller is actually going to try and tighten the nut itself. So it's easy to do that way. And of course I've already tested this motor, so these are already set in the correct place. The next thing you need to do is, well, it's good to do, very good to do, is to have a test net. So just to move the camera here, what I actually do is I've created this shield from wire mesh and just wired a couple of wooden ribs into it with the actual wire, and that kind of stiffens the whole mesh up, and then I can just slide it on the table, and there's a few clamps I have on that table that keep it held in place. There, now everything's in place with the test stand, and it's a lot safer to use, although you still have to use safety glasses in this configuration, because this isn't glass, and it's always just a good idea to have safety glasses on. But in this configuration, I can just power it up, and this is the last essential part of the process, and this is the power supply. This is the Voltec 50 volt, 50 amp power supply, and it's a lot more power than I need usually, but I do need the voltage. I do need the ability to go up to 50 volts for a lot of 8S, 6S configurations, and at that voltage range, you can expect to draw over a couple thousand watts in some cases, and this test stand can handle a lot of thrust, so this is a great power supply for that, and it works really easily for my application. This isn't really a manual on how to use a power supply, but when I turn it on, it instantly goes into constant voltage mode, and that's what I can use to power the test stand. Has a nice air switch in the back, makes things really safe. And I can turn the power on and off from here. Although it takes a while for the voltage to drop, so usually I just turn the power supply off. Turn the power back on, and usually I don't test. For example, if I'm doing 4S, I don't do multiple of 4.2 volts. I do multiple of like 4 volts or 3.8 to simulate the voltage drop in the battery. And this power supply is great, or any power supply would be great, because you don't have to recharge the battery to test your props and motors, which is really great because the voltage drop, even between one 30-second test and the next voltage drop, can skew your test. And this just has fine and coarse voltage controls here. And then the last part of the system is the software. So to go over the software, you can set your own language, motor parameters, units, firmware, working directory. So this, if you change this directory up, it'll save all the tests. I have mine set to documents, so every time I run a test, automated script here, it'll go to that. You can set the correct version here. So I do 1585. This is where you would enable the experimental scripting mode, which they require you to opt into for safety reasons. And then here's the important parameters for your motor. So don't forget to switch this up if you're not dealing with a conventional 12N 14P brushless motor. I don't really use the debug script a lot because I haven't really had a lot of errors with the RC or any. I haven't ever had to use this tab, and I'm not good at JavaScript, so I don't know if that'd be useful for me. But let's connect this here. As simple as just plugging it in after you have it installed. Remember, this is the USB cable we had plugged in. The blue cable we had plugged in over there. Utilities, yeah, so this is a great place to be able to adjust your PWM ranges. Say if you have a weird ESC, you can calibrate that here. Say if your ESC is starting only at 1500 and for some reason you can't recalibrate your SC, you can just enter that in here. And the ranges, usually in RC, at least the PWM ranges are between 1000 and 2000, so minimum throttle isn't 0. Yeah, the ohm meter isn't too accurate, but for conventional uses, a piece of equipment to measure this accurately is going to be thousands of dollars by itself, and this test stand's only a couple hundred. So these are your calibration protocols, and if you don't have the manual, this will read you through the calibration steps itself, and these are other ways to tear the ESC. So you've taken a look at the utilities tab. Now we can go to the safety cutoffs, which is excellent because you can set upper and lower boundary conditions for pretty much any variable you can think of coming out of the test stand itself. And yeah, that's very useful, including the vibration RPMs, not just power, thrust, and other electrical properties. This is where the test stand is controlled. So you have to check this checkbox right here, and the ESC will signal that it's got power and armed, and then you can vary it yourself here. And you can actually use this to calibrate your ESC too if you use the power supply in conjunction with the check mark. That is, your ESC is compatible with the traditional calibration method using only the radio and power. Not all ESCs are that way. But if I full screen this here, you can actually see that you can tear the load cells every couple tests if your thrust is off. So here it's off by 1.6 grams, so I can tear that. Or the noise will be the same, but the actual average thrust will be about 0. And yeah, you can make as many tests as you would like here. So if you're doing tests manually, you can record these numbers, or if you have other tests you'd like to do, you can record automatic, or you can record manually here, and say you take a sample, and it will just keep adding lines to a column of a file here. So yeah, these are just CSV files, and you can take another sample. It says 3 samples saved. Reopen the file, and it'll have the third line. If you enable continuous sampling, it'll add a lot of data at once, like so. This is the same file with the 3 original tests and about 40 rows of automatic tests. And then you want a new log, you just record the new log. Turn continuous recording off and take a sample. It'll tell you that there's 1 sample recorded in the new log. You can see there. Great part about this is the spacebar is the off tool. So if there's something that you see wrong that hasn't triggered any of the safety cutoffs yet, you just press the spacebar here. And then you have to uncheck the arm button and check it again before you can manually control the curve again. Uncheck that when you're not in the manual control tab for your own safety. And if we go down to automatic control, this is excellent, configured to do a measure of things. So you can actually measure the kV of the motor. So to do this, you would have to take the propeller off, and I would recommend running it at low voltage, like 8 volts or 4 volts. Some ESCs won't work at 4 volts, or they have minimum voltage to work. So as low as you can get the voltage to work, the better, because the motors spin very fast, and you don't want to test a kV of a 3000 kV motor at 4S unless you want to I don't know, explore how fast you can make your bearings spin before they fall apart, and also incur all the resistance of running that fast in your test. You can actually automatically test how many poles your motor's using, which I haven't used before. The interesting things are this continuous and discrete sweeps. So that your continuous sweep will actually act as if you had your hand on the throttle and you were slowly over time continuously moving it to max throttle. And this can be good or not good. Technically it's not steady state, but you can do it so slow that it is close to steady state, and it will give you lots and lots of data, and it will look really smooth. But if you're running a very powerful setup, then your motor may not be able to take a long time to throttle up to the point where the time taken could be too long, and you will not be able to slowly ramp the speed of the motor without burning either your ESC or motor. If you really want true steady state, then you can do discrete sweeps, which will go in steps to the max throttle. And both of these options have a reverse, so we can go up and down. You can change your ranges here for the PWM if you have a weird ESC or you just don't want to test at full throttle. In the discrete test, you can change the number of steps, stepping time before your measurements will start being taken, so you can actually reach steady state after the initial acceleration to your new throttle, and the number of samples you would like to take during the step. So this is a really great test, and I've been able to use this code to solve a couple of problems, like dealing with folding propellers. They like more steps rather than fewer because they like to get stuck if they're accelerated too quickly in an unbalanced position.
and I've used a sweep test a lot to do. People like to see how their propellers react quickly too, right? So if your propeller is very heavy, something like a quick continuous sweep would show a disadvantage there compared to a propeller that was produced with a carbon fiber or lighter material. You can do custom steps, and that's a little bit more tedious because you have to fill in all the variables, an option for you if you have a certain flight profile you want to get in. And these are some of the custom scripts I've set up, and I can just run one of them here. I don't need to clone it, but if you'd like to use any of these, you can clone these scripts. But if I have one I already like to use, then I can just simply run it here, and I'll turn the power back on, and you can plot the acceleration, which would be the vibration. Here I can do thrust and acceleration. So the script is finished here. I'm taking the time to install LibreOffice so I can actually show you what's going on here. And you've already seen these CSV files before, but this time with the automated test, you can see the ESC signal ramping up. The PWM is right here, and it arms 8 seconds in after waiting, and ramps to the 1360 throttle point that I had specified. So this is very useful. You get 2 of these tests, you can compare them. You can plot the thrust versus the PWM for 2 different props. I would suggest not doing that. A good thing to do instead is plot the thrust versus amps, and that way if you're testing 3 versus a 4-inch propeller, or even a higher pitch propeller versus a lower inch propeller of the same diameter, you can see how much power is being drawn at each thrust, which is much more helpful metric, because in a lot of cases you'll have propellers that trade efficiency at different RPMs, and of course the thrusts are different at RPMs a lot of times, so it's kind of a complicated scenario where sure your propeller could be producing less thrust at the same RPM, but it could be drawing less amps at the same thrust as the other propeller. And this whole sheet is spec'd with as much detail as you could want to know about anything. And this is the step test, so it's actually averaging over the continuous measurement at 1 throttle, so the test is a lot cleaner to look at, whereas the continuous sweep is just a ton of data sometimes. Here you can see the neat steps in the ESC signal from 1000 to 1500 like we asked for. Acceleration, that's measuring the vibration in every direction. Torques, thrust, voltage, current, and we have the motor electrical speed because we've connected one of the motor pins to the RPM sensor, which is a great way to do it. You also have the option for an optical sensor, but the great part is this RPM has been recorded, and now the script automatically calculates the efficiencies of the motor and propeller separately because it knows the speed and the torque, so it can differentiate the mechanical power for the motor from the electrical power going into it. And because this is a steady state, because it's not accelerating, the torque from the motor matches the torque from the propeller, so you can interpret both of them as a shaft power, and the motor's efficiency is kind of subtracting from the electrical power, and that's from this RPM right here, which is great. It's a really great tool. Without the RPM, you can't derive these numbers here. I hope this was a good review. I think that the test stand is great. The only thing I think would be better if it came with thumb screws for the actual motor, because it is a little hard to get in behind the motor there with a small Allen key. A lot of the times, because of all the fine parts, you end up dropping screws and stuff frequently. So that's the only real downside I can really say for this thing. It's very undervalued product. There's a great team, RC Benchmark, and they really give you everything you could possibly need to create your own testing environment. I mean, even just for evaluating motors by themselves, the amount that you can measure vibrations and kV and I/O with this thing. So it's not only a propeller evaluating device, but also brushless motor device. And I really can't describe all the stuff you can use it for. It's because you've got coding access to control your own scripts, so it's very, very useful. And I've been using this test stand for about 5 years almost, or versions of it, and I can't suggest a better option out there on the market. I mean, maybe if you just have one thing to test, you could use one of those cheap Hobby King test stands, but if you're swapping parts in and out, it's worth it just on its own for how easy it is to swap the electrical leads out and get the RPM information out. So I really like it, and I suggest it for anybody else. This isn't sponsored by RC Benchmark, although I did get a discount on their price for having purchased so many other test stands. So I'm going to have a link for their website in the pages below. They have smaller and larger test stands, much larger test stands. So thanks for your views, guys. Thanks if you watched till the end. Leave a like if you like the video, and if there's enough people that like this video, I can make another video on a script I've made to automatically interpret these CSV files into graphs, which you can compare two or more propellers in. Yeah, if you like this video, give it a like, and I'll catch you guys next time. Bye.